Hi, welcome to the pre-calculus lecture series. And in this video, we're going to cover section 3.2. So we're going to take a look at the polynomial functions and what their graph looks like. All right. So for the first section, section 3.1, we talk about a very special polynomial functions. We call it a quadratic, right? So it's only the x squared term. So for this section, we're going to take a look at the general polynomial function and what is their graph going to look like. Okay, so let's go to our lecture notes and let's take a look here. All right, so here, this is our lecture notes. This is a pretty big sections here. Okay, so let's start. So the polynomial functions, right? So this is how do we define the polynomial function is px is equal to an xn squared plus an minus 1 xn minus 1 and plus plus a1x plus a0. All right, so few things we need to be careful here. So the highest number for your x power, so like here is n here, right? So we say this is the n degree. Okay, so this is the n degrees of the polynomial. Or you can say it's the polynomial with n degrees is n's, right? Okay, so like a quadratic we did the last section is like we say it's a the x squared plus bx plus c, right? So the highest one is 2. That's why in the previous section we say, hey, this quadratic is is a special polynomial with a degree is 2. So here, okay. So the next thing here we're going to be careful is this number, this a0. All right, so a0 we call the what here? A0 we call is the constant term, right? So this is our constant term because there's no x associated with that. And now, and so and other things here, those numbers here, like an minus 1, a1, all those numbers, what here, like an minus 1, to a1. And all this here, and okay, so the a0 also, right? All this we call it is a coefficient. So the coefficient of this polynomial, all right, those just terminologies here. Then the next ones here is quite important. We say is this one, an, all right? So the an's here, because this is in front of the xn squares, right? So an, we call this the leading coefficients. Okay, so it's the leading coefficients. That means it's the coefficient of the highest degrees for your polynomials here, all right? Then the whole things here, so the whole an, xn, we call this the leading terms here, right? So that's the highest terms here. Okay, so what is the polynomial going to, the function of the graph of the polynomial going to look like? The polynomial graph is what has to be, we call this the smooth, continuous graph. Okay, so that's why we're going to, talk about like later. So how do we define what is the graph looks like? So let's take a look at this ones here. So if I have a graph here, right? So if I have here, and then I have something like here. So this graph, this is not a polynomial, right? because of y is not a continuous, it's a break here, okay? And then let's take a look at the other ones here, okay? And so this one's here, okay, you said the break you don't like, okay? So let's see here, so if we have something like this, okay, so in here, let me try to graph it a better way. All right, so here that means I have a up and then we go down for here. Okay, so if this is the graph, and this graph, we also say this is not polynomial. Why? Because I have what? I have this sharp point. Okay, so I have this sharp point. So remember, the polynomial has to be what? Okay, so I have this sharp point, right? Polynomial has to be smooth, all right? Okay, so now let's take a look at this ones here. Okay, so this one here is, okay, so let's see here, use different color. So if this one go like this, and then we say, yes, this is a polynomial because it's smooth, right? And so the same way is here. If I have a graph here, so if I have something go like this, and we will say, yes, this is a polynomial. It's a smooth, continuous graph here, right? So you cannot have any sharp point. And then, so we know the polynomials go up and down, the things, right? So then the next thing here, we're going to take a look what is the end behavior, all right? So the end behaviors, right? So what is the end behavior? So end behavior is like this graphs here, right? So, and my, when the x approach to infinity, in fact, infinity are going up or going down, that's what I call this end behavior. Okay, so let's hear, this is f of x, right? So this is an x to n plus an minus 1, x to n minus 1, plus a zeros, right? So we know n is what? N is the degrees, right? Okay, so now, so this is a degree, so this is a degree n's, right? So this is the polynomial with degree n here. So first things here, so okay, so we said when the n is odd. Okay, so I better use the same notation instead of put big n's here. So that means when the n is an odd number, that means if you have a third degree, fifth degree, and so if n is an odd number, so when you graph it, okay, so you have to have one leg go up and one leg go down. Okay, so when n is odd and an, if an is greater than 0, okay, so everything is positive here, right? Be careful here. These are the two numbers. We need to be very careful here. So that means my graph here. Okay, remember n is odd. That means one leg has to go up and other leg has to go down. See here. So in here, so for example, this will be some type of the graph I'm going to have. Of course, like in here, I know the end, right? So that means if a is greater than 0, the right leg go up, left leg go down. Of course, it doesn't have to be like in here, like only here, right? So in here, you can have like many different ways. So maybe you can do like this, right? This and this. But till the end, one need to go up, one need to go down. And when the a is greater than 0, the right side go up and the left-hand side has to go down here. All right. Okay, so now the next one's here still is odd, right? But then when the an is less than 0, if this is less than 0, so what is your graph going to look like? You still have one go up, one go down, right? So that means whatever the polynomial going to be, right? So now the left hand leg going up, right leg going down. Just like we talk about in between here, right? You can go many times, but the final one, right, is going down. And this final one is going up here. All right. That is when you have an odd. And then if when the n is an even degree, so if you have an even degree, so what's that mean? Okay, so if an greater than 0, so when the even degree, that means when you graph it, both of them going to go up and go down. So like in here, you can have like this, right? So then, because an greater than 0, so both of them going to go up. It's just like the quadratic, right? A greater than 0 is open upward. Okay, so the same thing here. If an is less than 0, what happened here? Then that means both of your legs are going to go what? Going down here. Okay? So both of your legs are going down here, right? So that is what we call this the end behavior of the polynomials here. All right. So then here, remember the key things here, right? So here, this is you need to remember, right? So it's even. So both go up and go down, depends on the an. And if this is odd, right? So if it's odd, and one leg go up and one leg go down, and it depends on, so like is the an the leading coefficient. That's why I say it's very important here, right? Okay, so then the next ones here, they say determine the end behaviors, right? So the end behavior, okay, so first take a look here. What I have here, an is what? An is negative, right? So this is my an is negative. And what happened to the degrees here? Degree is even. So I know the end behavior of these ones here is going to both going to go what? Go down, right? So both going to go down, right? Because it's even degree, negative is go down. So your graph, if you graph it, it will be something like this. If you put it into your calculator or some graphing device, and that's what is this graph, because the both legs are going to go down, is because it's the an is negative and the x is the even degrees. Okay. All right. So if we talk about the zeros, when I talk about the real zeros, it's not means we have a fake zeros here, right? Okay, so this real zero mean, that means 0 is a what? It's a real number, right? We of course we have I think like in your algebra, we talk about a complex number. We can have a complex number, but we're not talking about it here. When we talk about the real zeros, that means they are the real numbers, right? So what is the zero means, right? So we know if C is 0, C is 0 of a polynomial x, right? That means if you put the C, what you're going to have, the function value will be equal to 0 here. Or, okay, that means for your polynomials here, if C is equal to 0, this is a very good property. You can always factor the C out. So you can say x minus C, then times some other function qx. So you can always factor. So for examples here, if I have a px here, I have like x minus 2, x plus 1. That means I have how many 0? I have two zeros here, right? So you set this equal to 0, this equal to 0. So x equal to 2 and x equal to -1. All right. And so that means you can factor that one out. So what's that mean? So because we say this is PC equal to zeros, right? So really the 0 really is also is the x-intercept of the px, right? So because the x-intercept, that means y equal to 0. That means px equal to 0. Of course, because it's the polynomials, right? They could touch the x-axis several times, right? So they could touch the x-axis several times here. That's why. And also when you try to find the 0, one of the things is here, right? So you typical what? You typical factor the px in order to find the zeros, right? Okay, just like the example we did here, you factor it, and then we can find the 0. And then the next things here we're going to talk about is the intermediate value series for the polynomials here. So the intermediate value series for the polynomial, what is that? You're going to see this in the calculus 1 also. It's a very important series, right? And so let's say it's kind of like a common sense. They say if P is a polynomial, okay, and so P is a polynomial, and if you have a true value PA and the PB, they have opposite sign, right? Then there exists one at least, right? One value of C between A and B, between A and B, such that, so for which f of C equal to 0. Wow, what's that means? Okay, so this one, I said it's very kind of common sense is in here, right? So they say, if I have two values here, okay, so if I have two values here, here, let me move this one down a little bit, right? So, okay, so I say if I have two values, so this is A, this is B. So let's say you have FA and FB. So for example, this is F of A. Then let's say have an opposite sign. So this is F of B. That means when the values here and the values here, right? So here the keyword here is they have opposite signs here. Okay, so now let's take a look at what that means here. So let's say, hey, if this have an opposite sign, because we know the polynomial is continuous, so from A to B, you have to go through something, right? So we have to touch it. This is not a very good graph here. Okay, so like in here, you see here from A to B, right? So if you, in order to reach from the A to B, what happens here? You have to pass in the x-axis. You have to pass in here. Why is you have to pass in? Because polynomial is continuous and is, cannot break. So they have to go through that. So that means so this is a 0 for this polynomial functions here. So this is one of the methods, like you can use a computer to simulate it. So if you can find one interval, f of A greater than 0, f of the B less than 0, then this has to have roots in there. So in fact, in the real life, how to find the roots is kind of like not an easy it's not an easy task to do. Okay, so now let's take a look at some of the guidelines for graphing the polynomials here, right? So graphing the polynomial is, well, it's a little bit harder than graphing the quadratic. So the first steps here, so step number 1, okay? So how do I graph so the step number 1, okay? What I need to do, find the 0, okay? Finding the 0, if any, right? So find the 0. What I find the zeros here, so I factor the polynomial, right? And then set equal to 0. Then set equal to 0. Then set each factor equal to 0 and solving x, right? So those are the what? So the 0, like we say, those zeros are also what we call is x-intercept. That where is the graph going to pass. Then the next things here, we're going to find a few test points. Okay, so you need to find a few test points to help you, right? So in here, so what is the test point here? So basically you want to make a table. Okay, so you want to make a table of the values, okay, for the polynomials, right? Okay, so you want to find something in between. So if you can find them, so you will know, you might not know exactly, but you can get the ideas, right? So we're going to do some example. First, third one's here, right? So you will need to find the end behavior. End behavior is pretty easy, right? So the end behavior, let's see, you want to see is even degree, odd degrees, and then what is the, it's going up, going down, right? Okay, so after that, then you can also find so you can find find the y-intercept. This one maybe can help also. So y-intercept is set the x equal to 0, so it's pretty easy to find. Then number 5 is here, your graph, right? Make sure you use a smooth curve, right? Right, because we know the polynomial is a smooth and continuous curve to connect, right? Okay, so now let's take a look here. Okay, so let's say the sketch the graph of the polynomial. This one they already, factored for us, so easy. So I set each one equal to 0, this one equal to 0, and this one equal to 0. So what is my x value going to have? It's -2, 1, and 3. So I know my x-intercept will be at 1. So it's here, 3 is here, -2 is here. I know my graph going to go around and through those points here, right? Okay, so now the next thing here will say, hey, I'm going to find, like some testing points here, right? So the testing point, all right, so the testing point, so I'm going to have x and f of x, right? Okay, so so if I were you, so like here's x equal to -2, right? So I'm going to find something, right? So the equal to, let's go to the left-hand side of it. So I said the x equal to -3. So the x equal to the -3, then you plug that one in, you will get a -24. Okay, so I find this point So -3 and -24. All right, so it's way go down here, right? -3 is here, go down here, right? So way down here, right? All right. So let's is the way down here, right? Okay, and then the next thing is here, I'm going to find something in between these two, right? So these two, I find the -1. So if you plug the -1 in, you get an 8. Okay, so so I know my so my next point is here is -1, 8, 1, 2, 3, 4, 5, 6, 7, 8. So it's here, right? So it's I know I'm going down, up, and down, right? Now I need to find the y-intercept, right? So y-intercept is x equal to 0. So when you put the 0 in here, what I have a 6. So I know I'm going to passing through, y-intercept is 6. I'm going to passing through here. Okay, so now I'm going to find another point. So this is 1, 1, 1, 2, 3. So let's try to find the 4 to see what is the 4 will looks like. So for the 4, you plug it in, it will be equal to 18. Okay, so the 4, that means this is 1, 2, 3, 4 is 18 is way up here also, right? Okay, so the end behavior, right? So let's see here, the end behavior. So this is x, x, x. So degrees n is equal to what? Is 3. So we know one leg going to go up, another leg going to go down. And because all the x cubed, so the an is x cubed coefficient, so it's 1. Right, so I know the right leg going up, left leg going down. Okay, so now I can have a good idea. So I know I need to passing through this point, right? So I have to go down here. Then in here, I go here, then I go here, right? Okay, so here, now, all right. So now I know I need to go over to this x-intercept again. So I need to go up again, right? So now you go here, and this will be your leg, right? So you can get a pretty good kind of idea what is your polynomial going to looks like. All right. Okay, so now the next thing here is, let's say, hey, let's try to find all the zero, and then I scratch. Okay, sketch the graph, right? So let's try to sketch the graph here. Okay, find the zero. So we say, how do we find the zeros here? Hey, let's factors here, right? So minus 3x. Okay, so I factor the x out. So this is x squared minus 2x minus 3. So that is x minus 3, x plus 1. Then you set each one equal to zeros, right? Okay, so what is the x here? X equal to 0, x equal to 3, x equal to -1. Okay, so now let's kind of graph it. So this is x equal to 0, x equal to 3, 1, 2, 3 here, x equal to -1 here. All right. Also, this is the cube. So this is the degrees is 3. So I know it's the odd degree, and the constants here is positive. So I know my graph has to go something like this, right? The end behavior. Right hand side need to go up, right? Okay, so now we just like we did before, let's choose a few points. So to make our graph is a little bit more accurate, right? Okay, so now I do that. So I say, hey, this is -1, so I choose -2. So if you plot -2, you will get a -10 here. So let's plot it. So -2, -10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, up down is here, right? Okay, so then we're going to choose here, be careful. We need to choose a point in between these two, right? We need to choose a point in between these 2 points so we can know the behavior of, is it going up or go down, right? Okay, so I choose the -0.5. If you choose negative 0.5, you substitute to there, you get a 0.75. All right, so I know negative 5, so it's this one is going up somewhere here. All right, so this, did I do that right? Okay, so the negative point, oh, so this, I'm sorry, so it's not not 75, not 0.75. So this is the 7/8. Okay, so this is 7/8, but still it's about the same, so pretty close to 1. Okay, now I need to choose one between these two, right? Between 1 and 3, 1, 2, 3. So I choose what? I choose 2 to see what is the behavior. So the 2, I get, you substitute here, I get a negative 6. Okay, so this is the next one. Here's 2, 1, 2, 3, 4, 5, 6. I have 6 here. Now, so I know is you have to go up, passing here, and then passing over here. Then let's choose the 1 at the end. So this is 3. Let's choose 4. Okay, so get the same color. So let's choose 4. So the 4, it will give you 20s, right? Okay, so here, the 4 here will give me way up here, right? Okay, so now because I know the end behavior, so I know the graph should look like this. So, oops, very difficult to graph in the writing pad here. Okay, so here, this is go down. Then I know this need to go up a little bit. And here, and then here this go up and then go. Of course, here is to go up like here, right? So this is what my polynomial going to looks like. And then you will ask questions, is this -2 is the minima? No, we don't know, all right? So here, this is just approximate the shapes here, right? So we don't know if this is the maximum or not, you know, so let's, you know, they could go like in here and then go down a little bit more and then go up. You know, they could do that. And that's why in the calculus, in fact, they will teach you in the calculus, they will teach you how to find where is the maximum, where is the minimum goals, right? Okay, so let's take a look at another example. This is -2. Okay, so now let's see here. I want to find all the zeros. So find the 0 right now. I think everybody should have the ideas, right? So this is 2x4 minus x cubed plus 3x squared. So factor the x, you know, minus x2 out. So what do you have here? So you have 2x squared minus x plus what? Plus 3. Okay, so factor, so it's negative x squared. Then this is 2x plus 3. I assume you know how to factor it, right? X minus 1. Then what happens here? You set this one equal to 0. This is equal to 0. And then this is equal to 0. So what is your value? X equal to 0. X equal to the negative 2/3. X equal to what? X equal to 1. All right. Okay, so that means they're going to pass these few points, right? Okay, so let's try to mark it. So x equal to 0 is here. X equal to negative 2/3. Let's put 1 is a little bit bigger, you know, so that we can. All right, so now let's say here, this is 1. Okay, so this is 1. So 1, 2, 3. So let's put this is 1 here. This is negative 1, 1, 2, 3. So this we can 1, 2, 3. So we can graph better here. Okay, so 0 is here. Now x equal to 1. So that means going to pass through here. All right. And then the next one is here, x equal to negative 2/3. X equal to negative 2/3 is here. right? So I know my graph going to pass those, those few points here, right? So the 3 over, oh, not the 3, not the 2/3, okay, 3, I keep telling you guys need to be careful about the algebra. I made a mistake. So this is negative what? 3/2. All right, so the negative 3/2. So this point, 3/2, negative 3/2 with 1.5, right? So it's somewhere here. Okay, so now let's try to choose the test point. Remember the test point at each interval, you need to choose one. All right, so now this is negative 1.5, right? So the first point I'm choosing is negative 2. So it's negative 2, you will get a negative 12, okay? Okay, so here, this is negative 2, I get a negative 12, it's down here. All right, so the next one, I need to choose somewhere in between. So this is the one, so I choose negative 1, okay? So negative 1, you have is 2. Okay, so I know this one, I'm going to graph negative 1 is 2, 1, 2. So this will be the graph here. Then I need to choose somewhere between 0 and 1. So let's choose 0.5. Okay, so let's choose 0.5. So if you plug in the formula, I will get a 0.5 here. Okay, so that means 0 and 1 is 0.5, right? So it's 0.5, so it's somewhere here. Okay, and then, right, I need to choose the one greater than 1. So what is that? Let's choose 2, see what happened. Okay, so if let's choose 1.5, so then I need to choose 2 here, right? So 1.5, okay, so let's choose 1.5. Then if you plug into the formula, you get a negative 6.75. Okay, so then 1.5 is here, right? So negative 6.75 is close to 7. 1, 2, 3, 4, 5, 6, 7. So it's somewhere here, right? Okay, so now the end behavior, all right? So let's check end behavior. This is a force. That means that the both leg has to be go up or go down. This is negative, right? So if this is negative, so I know what happened here. That means that both my leg has to what? Going down here, right? Because it's a force, it's even degree, and the negative, so both going down here. So let's take a look here. So this is how we graph it. Okay, so I'm going to go here. So this one's here. So then they're going to passing here. Then they need to pass in the 1. So they're passing 1 here. Then they need to go a little high. Then they need to go down, passing here, and going down. Right? So that is what is by polynomials here. Okay, so now let's do, okay, so now let's do other ones here, all right? So the other ones here, we did a lot. So, I think we should be very good at the, those type of the problems here. So let's take a look at this one. Okay, so these ones here, that's factors, right? So factors here. So, okay, so I can group these two, right? So px, so I can say x squared, I can take this is x minus 2 out, then minus 4, so this is x minus 2, right? So I group, factor by groups, right? I group this one and I group this ones, right? Okay, so now in here, so x minus 2, the factor out, I have x squared minus 4. Then what happens here is x minus 2 and x plus 2, right? So this is x minus 2. I use a squared minus b squared. So this is x minus 2, x plus 2. So this end up with x minus 2 to the square and x plus 2. Okay, so now I find the 0, set this one equal to 0, set this one equal to 0. So what is my x? X is 2 and what? -2, right? Okay, so x is 2 and negative 2 here. So let's also, just like we do last time, let's get a little bit bigger so that we can see better. So this is 1. Let's say this is 1, this is 2, right? So this is 1, this is 2. So this is -1, -2. So I know my 0 is at where? 2 and -2. So it goes through here, goes through here, right? Okay, so when I go through here, okay, so let's see here, right? So in here, now I need to do the test point here. So the test point, so this is f of x here. I choose something on each interval. So less than 2, but I choose -3. Okay, so if -3, I get a -25. Okay, so I will get -3. So here is a -3, right? So -25 is way down. Okay, so let's see here. So this is -2, here, this is -3, right? -3, -3 is -25, it's way down here, right? Okay, so now I need to choose something between these two, right? So I choose -1, right? So I choose -1. What I have 9 here, right? Okay, so let's plot -1, I have 9, so it's somewhere here, okay? And then I need to choose something greater than 2, so I choose this is 3. Okay, so this is 3. So if I choose 3, I plug it in, and this will give me 5. Okay, so here, let's take a look here. 3 is here, give me 5. 1, 2, 3, 4, 5. So it's here, right? Okay, so this is 3, right? Because right now we use every two things as 1. Okay, if this is 3, let's take a look. This is how many degrees? The third degree. So n equal to 3, an equal to 1. So third degree positive coefficient. So I know my graph has to be like here, one leg up, one leg up, down, right? Also, yeah, here, if you like, you can choose like the x equal to 0, then you got 8. That will give you the y-intercept. That will give you some ideas here. So this is y-intercept. So I know this is what is my graph going to look like, right? Okay, so when here this is 3, right? So I know I'm going to pass in here, then go all the way up, maybe here, then go down here, and then what? Then in here, all right? Okay, so in here, so be careful, right? So here, so you say where I'm going to turn. All right, so think about it. For this graph here, right? If you go passing through here, because, you know, at x equal to 3, it has to be here. If you're passing through, you have to turn back somehow. Right, when you turn back somehow, you create one more 0 here. But in here, I only have 2 zeros, right? So I know I cannot passing down here. So that means the only way I can do is I touch the 2, then boom, go up like this one. So the 2 has to be tangent at the x-axis. So if you take a look, right, so because you cannot going down. If you're going down, you're going to create one more zeros here, right? So here, this is what we call the, so x equal to 2, because we know for the polynomials here, right, if third degree, I'm going to supposed to have 3 zeros. So, but in here, I only have 2 zeros. So what happens here? This 0, right? Because this one is come out from the x minus 2 to the square. So this 0 really is 2. Sometimes we call it is the double 0, right? So that means it's happened twice here. So they both happen here. So this is what we call is multiplicity. multiplicity, that kind of very difficult to pronounce word, multiplicity. That means, you know, that this zero is doubled or tripled or fourth here, okay? So this is come to a very, you know, important point here. So you notice, you know, I have to have 3 0, but here I only have 2. That's why, man, these zeros here, I need to kind of like just turn right at the x-axis here, right? So it's like a tangent lines here. Okay, so the graph of the 0, so what happens here when the multiplicity is ends here? Okay, so so here we need to take a look. This is very important, right? So I said here, if the, okay, so here if n, if its multiplicity is odd, okay? So if a multiplicity is odd, and that means your graph, okay, multiplicity. So let's say that here, if we call this ones here, we say is multiplicity of C. Okay, n is multiplicity at C here, right? So if it's odd, that means your function. So here, this is a C, right? That means your functions here has to passing these ones here. Okay, so of course it could be passing a different way, depending on your leading coefficients, right? So if this is C, and if you have a multiplicity, so here, then they have to pass. And if, you know, if n is even, just like the one we just did, right? The n is 2, right? So in here, this multiplicity here is 2, it's a double, right? So it's 2 here. So then what is your graph going to look like? It's going to tangent the x-axis. That means you're going to touch that. So here, that's what that means here. So in here, you know, if this is your C's, right? So here, that means your graph has to touch it. Okay, so it has to touch it. So if this is the C, of course, this one can go, if that depends on leading coefficients. This is the C's, right? So then what happens here? So that means in here, right? So the graph will not pass, will touch. Okay, so that is the multiplicity of C is even or odd. It's super, super important, right? So you will get your graph is odd, they're going to passing. And if it's even, what are they going to do? They're only going to tangent, they're going to touch. Okay, so now let's take a look here, right? So graph the polynomial. So let's take a look at this one here, right? So this one's here, we say, the graph in the polynomials here. Okay, so let's see here. So this one equal to 0. So this one equal to 0, and this one equal to 0, and this one equal to 0, right? So I know what is the value of x here. The value of x equal to 0. And what is the multiplicity here? M is equal to 4. And the x going to equal to what? 2. What is the multiplicity here? Is 3. And the x equal to -1 here. What the multiplicity here is 2, right? So this depends on the here. Okay, so now let's try. Okay, so let's try to, okay, so let's try to graph it. So I have a 4, 3, 2, right? So let's get a little bit bigger number so we can see. So this is 1, 2, 3, 4. So this is 1, 2, 3, 4, right? So we know the multiplicity is at 4. So I'm going to touch here. I'll touch it, I'm sorry, not at 4 here. Okay, so we know the multiplicity is 0. Okay, so this is -1, -2, all right? So it's going to add zeros, right? Okay, so let's color that. So it's going to touch here, going to touch 2, right? And going to touch -1, right? Okay, so now let's do the same way, find the point here, right? So you find the point f of x. All right, so let's try. So I'm saying here, so it's -1. So I'm choosing -1.3, put it in, I get a -9.2. And so that means -1.3, -9.2. So it's somewhere here. Okay, so that's my point. Then I choose something then in between. I will choose the -0.5. So I will get a -3.9. So this will be my another point, -3.9, somewhere here. Okay, now I choose something between these two intervals. I choose 1, giving me -4. Okay, so 1 is -4, 1, 2, 3, 4 here. And then I choose the last point is larger than 2. So I choose 2.3. I got 8.2 here. So what is this one here? Okay, so 2.3 is 8.2. So somewhere here, right? And now take a look. This one's here. Let's see what is the degrees ends here, right? So what is the degrees end? Let me erase those marks so you can see, right? That's what is the degrees end. So this is a 4, and this one is 3, right? Then this one is a what? Is 2. So what is the degrees of ends here? Is 9 degrees, right? So for the 9th degree, and what is the constants here? Is what is 1? It's a positive. So this one here is 9th degree is a positive. So I know my graph has to be one end down, one end up. And this is the final graph going to looks like, okay? So now let's try to graph it, okay? So when the x hit -1, okay, so here this is going down, right? So when x hit -1 here, right? So be careful here, right? So for the -1s here, this is one of your zeros, right? So this is one of your zero, but the -1 is even, right? So that means I'm going to tangent that. So going to do like this, then going down, right? Then I'm hit the x equal to 0, right? So 0 is, so I'm going to go down and go up. 0 is another even multiplicity. So I need to tangent here. Then I continue going down. And then I go through 2. 2 is 3. So that's why I know, oh, I can pass through that. Right? So that is what is my graph looks like. Right? So that in here, be very careful here, right? So like in this 2 point, x equal to 0 and x equal to -1, both of them have even multiplicity. So that's why the graph cannot go over to the x-axis. So need to touch x-axis here. Okay? So that's why we said a local, okay? Okay, so the next thing here, we said here, okay, so we said, what is local extremus here? So this is very interesting also. So let's say if px, right, is equal to the an xn plus a to n minus 1, xn minus 1, then the plus a0. Okay, these polynomials, okay, at least, right? So this polynomial, the graph of the polynomial, right, has at most n minus 1 local extrema. That means you can be maxima or minima. So here, be careful the word at most. That means you cannot more than 1, right? So for example, the quadratic, right? Do you remember the quadratic, right? So for example, see here, the quadratic, we have like ax squared plus bx plus c. So my n is 2. So when the quadratic, how many local maximum have 1s, right? So it's 2 minus 1s here. That means if you have 5 degrees, you cannot have more than 4 terms here. Okay, so like in here, let's say graph the following graph and determine how many local, the extrema it has here. Okay, so here, the first one, look here, right? So this is x force. That means I cannot have more than 3, right? Because it's n minus 1. So I can only have a total 3 maxima or minima here. So let's see where. So I have a 1, 2, 3. So because basically also local extrema is also the place you make the terms, right? Right, so you make the terms. So for these ones here, it's match, right? So I have 2 local mean, 1 local max, right? So because x force. Okay, so take a look at the second one here. The second one is x5. So if x5, so how many max and local I have maxima I need to have? So I cannot have more than 4, right? So let's take a look. So this is a local max, local mean, local max, local mean. So I have 4. All right. Okay, so that means at the most, that's the, I can only at the most, right? So now let's take a look at the last ones here. The last ones here, let's say x to the 4th. That means I can have at most 3, right? So in here, how many I have? I have 1. Is that okay? Yes, because they say at most, right? So as long as I don't exceed 3, so I can have 1 local mean. It's okay, right? So that's why we say be careful about the word at most, right? That means you cannot exceed, the n minus 1 local extrema, right? So could be local max, could be local mean. When you add them together, has to be less than or equal to n minus 1. Okay, that's it, right? This is a very long section, but it's a very important section, give you the basic concept about how to graph the polynomial, right? So a few things we need to be careful, the leading coefficient and the behavior, and the multiplicity. So if you have even multiplicity, so you need to have a tangent at the x-axis. If it's odd, you go through the x-axis here. And the number of the term over the local extrema will be equal, will be less than or equal to the n minus 1. All right, that's it. Okay, I hope that you get a pretty good idea about how the polynomial looks like and how to graph it, right? All right, that's it. And looking forward to talk to you in our next videos here. Okay, bye.